Good morning, boys and girls, and welcome to math class. Yesterday in our Go Math, we looked at estimating and measuring with liquid volume, which is part of the metric system, and we're going to continue on measuring with the metric system, but today we are going to estimate and measure the mass of objects. So we're going to get started with a video because just like I talked about yesterday, we would be doing hands-on manipulatives in class. We would be using a scale and we would be holding items and moving things around and lifting things to see how much something weighs. So we can't do that right now since we're kind of all locked to our computer screen. So I am going to show you a video, actually I think two videos that will help us to understand what the metric system is and how it's used.
Hi, this is Rob. Welcome to Math Antics. In this video, we're going to introduce the concept of measurement, which is an important topic in math and especially in science. We're also going to take a look at a particular system of measurement called the metric system. Objects have different physical properties, right? Like size, weight, volume, etc. Well, the whole point of measurement is to quantify those properties, which just means expressing them as a number. Without measuring, you could say that someone is tall or short, or that a package is heavy or light, but those are relative terms that don't give us very specific information. Instead, if you were to make actual measurements, you could say that someone's height is 130 centimeters, or that a package weighs 5.2 kilograms. Measurements use an actual number to describe properties like that, so that you can know them more precisely. But there's a catch. Unless you know what a centimeter or a kilogram is, those measurements won't be very helpful. Centimeters and kilograms are examples of what we call units of measurement. Units of measurement are predetermined quantities that we use as references, and it's really important to be familiar with common units of measurement so you know what various measurements mean. Units of measurement aren't something fundamental to math, like addition and subtraction are. Instead, they're amounts that people invent and agree on so that we can communicate. In fact, we could agree to use just about anything as a unit of measurement. I could tell you that I'm 13 hot dogs tall, and my weight is 3,259 donuts. The problem with those units is that hot dogs and donuts aren't very consistent, and unless you and I are using exactly the same hot dogs and donuts to measure, we'll probably come up with different results. To get around this problem, the units that we use in math and science are standardized, which means that they match official standard amounts that can be measured over and over again to give exactly the same result. There's even a government agency called the Bureau of Weights and Measures that defines and maintains those standard amounts.
Well, what do we have here? Nothing, just measuring stuff. Let me see that. Ha! Just as I suspected, this isn't properly calibrated. I just had it checked. Yep, gonna have to take it into the lab for adjustments. Don't let it happen again. So, is there a number I call to get that back?
Of course, getting a bunch of different people to all agree to use the same standards is not always an easy task. And throughout history, a variety of different units have come in and out of popularity. For example, the ancient Egyptians used units like cubits and kites, which aren't so popular today. In modern times, there are still a lot of different units used in different countries, but the most popular system of units used around the world is called the metric system. Well, its official name is the International System of Units, or SI units for short, which stands for the French Système International. But the term metric system is still often used to refer to this system. The metric system is a really great idea because it makes the math involved with certain measurements and unit conversion much easier to do. That's because just like our base 10 number system, most units in the metric system take advantage of powers of 10. The idea behind the metric system is to quantity that uses the same powers of 10 prefix pattern, and that's mass, or weight. Mass is a measure of how much actual matter an object contains, which is closely related to its weight on Earth. In the metric system, the basic unit of mass, or weight, is technically the kilogram, but we're going to start with just the plain old gram to see how the same prefix pattern we use for length can be used for mass also. For reference, a gram is the amount of mass equivalent to 1 cubic centimeter of water. The mass that you'll most commonly encounter in everyday life are the milligram, the gram, and the kilogram. So make sure you're familiar with those. All right, so that's the basic idea behind measurement and the metric system. Measurement helps us describe things in the world we live in and to compare them using units. And the units in the metric system are specially designed to play well with our base 10 number system. But it's important to know that the SI, or metric system, does use some units that are not based on powers of 10, like time, for example. The basic SI unit of time is the second, but units of time that are larger than a second are still the traditional ones that are based on the motion of the Earth and the Sun, like minutes, hours, days, and years. Fortunately, units of time that are smaller than a second do use the base 10 prefixes, such as milliseconds and nanoseconds. I wish I had more time to talk about time in this video, and all the non-metric units that are still commonly used today, like feet or pounds, but I'm afraid those will have to wait for future videos. There aren't too many exercises for this lesson, but if measurement and the metric system are new topics for you, you might want to give them a try. As always, thanks for watching Math Antics, and I'll see you.
This lesson is estimate and measure mass. Okay, this is lesson 10.8, and our essential question is how can we estimate and measure math in metric units? Okay, so here we have a dollar bill. George has a dollar bill in his pocket. So should George measure the mass of the dollar bill in grams or kilograms? Well, a gram, you guys, and it's abbreviated with the letter G, is the basic metric unit for measuring mass, or the amount of matter that an object weighs, okay? But mass can also be measured by using a metric unit which is called kilograms, which is kg, okay? So should we measure it in grams or kilograms? All right, so a small paper clip has the mass of about 1 gram, okay? So, you know, everybody has small paper clips either in their teacher's desk or maybe your student desk at school. If you have 1,000 of them, a box of 1,000 paper clips, that measures the mass of about 1 kilogram. Okay, so I think that the mass of the dollar bill, what do you think it's closer to, the 1,000 paper clips or 1 paper clip? Well, I think it's probably closer to a small paper clip than it is to 1,000 box of paper clips. So since the paper clip was 1 gram, then George should measure the mass of the dollar bill in grams, okay? Easy enough. So here's some items that weigh about 1 gram, okay? Well, a small paper clip, we discussed that, weighs about 1 gram. Also, a dollar bill weighs about 1 gram. We talked about that. Cotton balls also weigh about 1 gram. So things that are really light, okay? A small business card weighs about 1 gram. Okay, maybe a dime. A dime also weighs about 1 gram. What do you think a nickel weighs, you guys? Is a nickel more or less than a dime? Well, a nickel's a little bit bigger than a dime. Nickel weighs about 5 grams, you guys. It's not quite a kilogram, okay? So items that weigh 1 kilogram, well, you know, the box of 1,000 paper clips has the mass of about 1 kilogram, so it weighs about as much as a kilogram does. Well, if that doesn't help, how about a liter of water? 1 liter of water also weighs about a kilogram. A pineapple, that probably weighs about 1 kilogram. A baseball bat weighs about 1 kilogram. Maybe 5 bananas also weigh about 1 kilogram right there. Okay, so how many grams are there in 1 kilogram? Well, if 1 paper clip is about 1 gram, and 1,000 paper clips is about 1 kilogram, then that means that there's going to be 1,000 grams in 1 kilogram, okay? So choose the unit that we should use to measure the mass. And so write gram or kilogram. Okay, so here's several items right here. We have a blueberry, a dog, glasses, a watermelon. So the really light ones, we're going to measure them in grams, and the heavy ones we'll measure in kilograms, okay? So blueberries, well, that probably weighs about 1 gram right there, okay? A dog, well, a dog is much bigger than several pineapples, so I would measure a dog in kilograms, okay? So they just want to know, should it be better to measure in grams or kilograms? Well, a dog would be definitely kilograms. It would be, since there's 1,000 grams in kilograms, then a dog would weigh several thousand grams, but it's better to weigh it in kilograms right there. How about some glasses, you guys? Do you think glasses weigh as much as, say, a pineapple or a baseball bat? I don't think so. So since it doesn't weigh as much as a kilogram, which is a pineapple or 5 bananas, you guys, this is much lighter. I would weigh this in grams. It would be more than a gram. It would be several grams. But if it doesn't weigh quite a kilogram, then measure it in grams. How about a watermelon? Do you think a watermelon weighs about as much as a pineapple or 5 bananas? I would think so. So I would measure that in kilograms right there. All right, you guys take care.
Okay, I hope those videos helped. So if you could open up your Go Math workbook. Oh, there's Judith in the background attacking the, hello Jude, attacking the pillow. If you could open up to page 605 in your Go Math book, we're going to get started on estimating and measuring mass. Okay, so you should be ready. And it says estimate and measure mass right up top. And it says the essential question, how can you estimate and measure mass in metric units? Now we've gone over what metric units are. It's the standard unit of measurement in definitely math and science around the world. And that way, if you measure in the United States in, let's say, Mercer, Pennsylvania with 1 gram, and then you go to Australia and you measure something there and it's 1 gram, then you know it weighs exactly the same. Whereas if you were to measure in Mercer, Pennsylvania using a carat, and then someone in Sydney, Australia was measuring with their carat, it could weigh different. Somebody might be using a nice big garden carrot, and then the other person might be using a little store-bought little carrot stick. So you don't know. So that's why if we are all using a standardized unit of measurement, we all know how much it weighs. All right, so we have Pedro has a dollar bill in his pocket. Should Pedro measure the mass of the dollar bill in grams or kilograms? So we saw that in the video, a dollar bill, and we learned that G stands for gram. That's the basic metric unit for measuring mass, or the amount of mass in an object. Mass can also be measured by using the metric unit kilogram. And we learned that the kilogram or kilogram is kg. Now I want you to look at both of these words. We have gram, it has 4 letters, and we have kilogram that has kilo, which is the prefix, and then you have gram, which is the root word. So you have 4 and 4, so there's 8 letters. That's how you're going to remember which one weighs more. Gram only has 4 letters, so it would definitely be lighter than kilogram that has 8 letters. So the longer word has more letters, which means it has more weight to it. So that's how I want you to remember which one is the larger unit of measurement. If you go down to the picture here, you have a small paper clip has a mass of about 1 gram. So think about if you put a paper clip in your hand and you can barely feel it, okay? But if you go next door and you put 1,000 paper clips in your hand, you can definitely feel the weight of it. So anytime, and this is another way, if you ever have to use a muscle to lift something, or like you really have to grasp it and lift, that's how you know you would measure it with a kilogram. But if it's something that is so light, like a paper clip where it takes nothing to hold it up, that's when you know it's very light and you're using 1 gram. Okay, so we're going to keep on going. So this is the one we already did. Go to your next page. We're just discussing these because we've already done it on the video. Okay, so here's a balance pan. So right here, you see this little girl. This is a balance pan. pan, it's just a scale, okay? Then we have grams and kilograms as our masses and some classroom objects. So we're going to go down and we're going to look at the actual objects, okay? So we have the little girl up here with the scale. So what we want to do is find the mass of each object to the nearest gram or kilogram. Place the object on one side of the balance, place grams or kilogram masses on the sides until both are balanced, okay? Now, we're just going to decide if we're going to use like a kilogram or closer to a gram. Remember, if you have to use any muscle, you are going to do kilogram. If you have to use muscle. If you use no muscle and it is very, very light, we're going to say gram. Okay? So we're just going to estimate because we don't have any of this that we can actually do together. So crayon. So pretend like you put a crayon in your hand. So pretend you've got that crayon right in your hand now. Did you have to use any muscle? So no, you didn't. So that would be a gram. A stapler. Is a stapler going to use, some muscle to pick up? Not much, but, you might say that that's a kilogram. Okay, like 1,000 paper clips. It probably weighs 1,000 paper clips. Then we go to an eraser. When you lift an eraser, it's really, really quick. So we're going to say an eraser. I'm not going to say it's 1 gram. I would say, an eraser, yes, you're going to use grams, but you're going to use a couple of grams, but nowhere near 1,000. How about a marker? When you lift up a marker, it's like very, very light. So hopefully you're thinking probably, maybe 10, 15 grams. A small notepad. So a small notepad, just a little one. Okay. So they don't weigh much at all. So you definitely wouldn't use one. You would probably use multiple. And it looks like I'm frozen down here. So hopefully this video is going to turn out for you guys. But I see that we're freezing down on the bottom here. I have no idea what it's going to look like when we're done. So we're definitely going to do a small notepad is going to be grams. Scissors, definitely grams. Okay. We can't do the bottom. We can't rate them in order. All right, so let's get started over here. And we're on the next page now, and it says choose the unit you would use to measure the mass, the metric measurement. Would you use a gram, which only has 4 letters, so it's very light, or would you use kilogram, which is a little bit heavier? It has 1,000 grams in it. So a strawberry. Put a strawberry in your hand. Do you have to use any muscle? Absolutely not. So it would be a gram. How about a dog? If I tried to pick up Judith, I think I'm going to have to use some muscle. So it's definitely going to be a kilogram. Compare the masses of the objects. Write if it is less than, the same as, or more than. Okay, so if we look there, we've got a scale that they're giving us. And it says the mass of the bowling pin, here's the bowling pin, to the mass of the chess piece. Okay, so the mass of the bowling pin, is it less than the mass of the chess piece? The mass of the bowling pin, is it the same as the mass of the chess piece? Or is the bowling pin, the mass of the bowling pin, more than the mass of the chess piece? So you have to look at this arm right here. This arm, if it's even and they are equal, it would have the exact same. I have a feeling something's wrong with my computer today. So it would be even. So you would have it so that it would look more like that. So you can see that this bowling pin is down. So that means it's heavier. So think of this as a teeter-totter. When you're teeter-tottering, the heavier person can hold you down, whereas the lighter person goes up in the air. Okay? So then that means that the mass of the bowling pin is more than the mass of the chess piece. So you go over to number 5. The mass of the erasers, is it less than, the same as, or more than the paper clips? And you can see the arm is directly the same. So if it was a teeter-totter, they're exactly the same. So it would be is the same as. So we're going to go to on your own. So take a moment and write if you would measure this with grams or kilograms. Go ahead, pause the video. Okay, so a chair, hopefully you said kilogram. Sunglasses, a gram. Watermelon, a kilogram. Number 9, you had to choose less than, the same as, or more than. So you're looking at the arm. The mass of the pen and the mass of the paper clips were the same. Then the mass of the straws, hopefully those are paper straws or reusable straws, since it was just Earth Day. And then we have 3 blocks. So hopefully the mass of the recycled straws or reusable straws is less than the mass of the blocks. And we're going to turn the page. And this is your problem solving. So it says put the sports balls shown at the right in order from greatest mass to the least. So obviously you guys all have knowledge of different types of balls. So you have a golf ball, a table tennis ball. So this is a ping pong ball. So think about a ping pong ball and the weight, a baseball, a tennis ball, and then a bowling ball. Okay, so we want to do what would be the greatest, the heaviest, what would have the most mass, weigh the most. So hopefully when you're looking at all of these, you are coming up with, hopefully, the bowling ball would be your first choice for number 1. Then I'll bet you went with your baseball for 2, the tennis ball for 3, golf ball for 4, and hopefully you came up with the table tennis or the ping pong ball as the lightest. Okay, so this would be like 1 gram. He'd be very, very light. All right, so then it goes on and says choose 2 objects that have the same mass. Draw the balance of the objects on each side. Okay. Then use diagrams. Choose 2 objects that have different masses. Draw the balance of these. So this would be something you could do at home. So you might want to choose a fork and a spoon, and they would balance. Then 2 objects that have different masses. Maybe you would do a fork and a glass because they would have different masses, different weights. And then pose a problem. Write a problem about the objects that you chose. Then solve your problem. Okay, so that could be like, is the mass of the fork more than or less than the mass of the drinking glass? And then you could solve it by saying the fork has less mass than the drinking glass. All right, so 15 cents or nonsense. Amber is buying a produce at a grocery store. She says that the Fuji apples are so delicious, and a green bell pepper would have the same mass because they're the same size. Oh, okay. Well, a Fuji apple, think about what it's filled with. And then think about a green bell pepper and what it's filled with. So hopefully you're thinking that no, it wouldn't, because the 2 objects, yes, are the same size, but that does not mean they have the same mass. The mass of the apple would be greater because the apple has a filling, a really thick filling, whereas The green bell pepper, all it has is air and some seeds in the center. So it would be open in the center. Number 16, select the objects with a mass greater than 1 kilogram. All right, so this one is, if you have something, you have to use your muscles, okay, even a little bit, then you're going to have 1 kilogram, which is like a pineapple or a loaf of bread, okay? So a skateboard, do you have to use any muscle to pick up a skateboard? So hopefully you are choosing skateboard. How about a laptop computer? If I lift up my laptop right now, I better use my muscles or I'm going to be in trouble because I'm going to drop it. A cell phone. Do you have to use much cell phone? Like, can you imagine if you had to use your muscles to hold your cell phone up or to text on it or play your games? You would have like huge muscles from holding your cell phone. So that one does not get marked. An egg. Oh my goodness. Hopefully you didn't mark egg. How about your desk at school? Pick up your desk at school. Oh my gosh, those are heavy. You have to use your muscles. And then a pencil. Hopefully you're not struggling to lift your pencil. Hopefully you are good there. All right, we're going to move on. So this is your practice and your homework. So I'm going to give you a couple of seconds. You're going to pause the video. You are going to choose the unit that you would use to measure. You're going to write gram. Remember, gram is very light. It only has 4 letters. If I held 4 letters in my hand, it would weigh less than 8 letters. It would be like this. 8 letters would be down here because it has more mass. Okay, more letters. All right, so I'm going to pause the video. You guys do your work and then come back to me. All right, hopefully you are back. So you would definitely use muscle for the boy. So that's a kilogram. A bag of sugar is usually 5 pounds, so that's a kilogram. You had to compare the masses of the objects and write if they are less than, the same as, or more than. So hopefully you wrote the mass of the candle. Here's the candle, and the teeter-totter is going down on this side, so the candle is more than the light bulb. The teeter-totter is even, so the mass of the watch is equal to or the same as the mass of the necklace. For number 6, it would be more than 7 kilograms. And then name an object in your house that has a mass of about a kilogram. So like my math book could be like a heavy math book, you know, that you have to use a little muscle, would be a kilogram. Maybe like a loaf of bread or a pineapple, or maybe like a full bottle of Coke, something like that. Something that takes, you know, like 1,000 paper clips. Okay, so we're gonna move on. You should have done your lesson check if I can get it to keep going. So number 1, you should have said gram. Number 2, kilogram. Spiral review, 6 groups because you had 24 dividing into 4 equal groups of 4. How many were in it? You would have gotten 6 groups. Clark used the order of operations to find the unknown. All right, so you would have gotten 11. See what we got here. So we would have done, I think that's the division, so it would have been 12 divided by 3 is 4, and then 15 minus 4 would have given you the 11 if you did order of operation. And then use the pictures for 5 and 6. Ralph pours juice into 4 bottles that are the same size. Which bottle has the most amount? Hopefully you came up with bottle A. Which bottle has the least? That would be D. All right. I'm hoping this video comes and turns out for you guys because it seems to be doing a lot of really weird things here. But I hope you have a wonderful day. I miss you all, and keep up the great math work. I'm so proud of you, and all of your chapter 12 quiz scores were fantastic. Very proud of all of your hard work. And I really enjoy when you've been putting stuff up on the screen for all of your friends and your classmates to see. I think that's wonderful that you're sharing. Take care.